In this video, we're going to look at different types of studies. And the two main categories of studies that we are really wanting to focus on and really compare and contrast with one another are observational studies versus experiments. Making a clear distinction between an observational study and an experiment and what each of these studies has the ability to do and not do is going to be really important. So just as we go through these, just really kind of keep in the back of your mind that the big takeaway from what we do today needs to be, do I understand what's happening in an observational study versus an experiment? All right, so we'll start with observational studies. So the definition of an observational study is it's a study where data is collected in such a way so as not to interfere with how the data come about. So think of it as you as the data collector are a passive observer and not interfering in any way. Observational studies come kind of in two ways. One is what we call a prospective study, and that collects information as events are occurring in real time. So an example of this might be you want to know what proportion of drivers appear distracted at a particular intersection. So you set yourself up in a place where drivers aren't going to necessarily notice you, and you just mark down whether they're distracted or not distracted, right? And you decide what that means, right? If they look down at a phone or if they look down at a radio, maybe you say that's distracted, and if their eyes are on the road, they're not distracted, right? So, but the idea is you are collecting the data as it happens in real time and not interfering with how the data are coming about. A retrospective study means you're looking into the past, right? You're looking at you're collecting data after events have already taken place. I would say the majority of observational studies probably fall into the category of retrospective, because even when you're talking about things like which political candidate do you prefer and those sorts of things that might be kind of phrased as if they are in present tense, presumably you've already made the decision, right, to support one candidate or the other. So even though I'm asking you who do you support right now, it's really a retrospective study because of the fact that you've already made that decision somewhere in the past. One example of this is that a few years back, Yakima County was actually in the national news because there was a spike in neural tube defects in newborns. So a neural tube defect is a fairly rare defect that newborns can have, and basically Yakima County just had way more of them than you would expect. And so researchers conducted a retrospective study where they interviewed the families extensively and tried to find out if the families that were affected by this shared any common risk factors. Probably the most well-known type of observational study is that of a survey, right? So anytime a survey is given, asking questions, that is an observational study because you're not interfering with how the data come about. You're just collecting the data by the questions that you're asking. So a good example is like political polling, where you're asked your opinion about a political figure or a particular issue. One of the things that's really important with surveys is it's important to carefully consider how questions are worded. That's really important. And here's an example of why that's important. So we have two studies. One study reported that only 13% think we are spending too much money on assistance to the poor. Okay? And I put assistance to the poor in quotes because that's how the question was asked, right? Do you think we're spending too much money on assistance to the poor? Another study reported that 44% of people think we are spending too much money on welfare. Okay? So if we suppose for a second that the two studies did use similar sampling techniques, what can account for these drastically different results? Well, it's all in the wording. So welfare is a word that kind of carries a lot of baggage with it. And when you think of welfare, people might be inclined to think of a particular government program that they've had a bad experience with, or maybe they just disagree with. But assistance to the poor, first of all, it's much more positive. It doesn't have the same type of baggage, particularly political baggage from rhetoric that the word welfare does. Assistance to the poor also is just assistance is a kind of a positive word. And when you think of welfare, you might, like I said, be thinking of very specific policies. And it's easy to pick a policy that you don't like, whereas assistance to the poor is a little more vague, right? It's not getting specific about how the assistance to the poor is happening. And so just by that little change in wording, and really the authors really mean the same thing, right? But the little change in wording gives drastically different results, right? So you really have to be cognizant of the words you're using and how that could affect how your subjects are interpreting the questions that you're asking them. All right, one last item that's really important to emphasize about observational studies is that causation cannot be inferred in any type of an observational study. All right, so let me give just an example here to set this up. So in my just very brief example, suppose that subjects in a study, so subjects report daily water consumption and weight loss over a period of time. Now, if they find that people who drink more water tend to lose more weight over that period of time, then a temptation might be there to say something like the following: increased water consumption causes increased, or I guess I should increased, or maybe I should just say more weight loss or something like that. Causes greater weight loss. Okay, that might be tempted to say that, but what we're saying here is that first of all, this study is clearly observational, right? We are not intervening. We are basically just asking the subjects, tell us how much water have you consumed, tell us about your weight loss. So this is an observational study, and on that basis alone, I cannot use this word, okay? I cannot say that increased water consumption causes greater weight loss, okay? What I can say is something like this: is associated with. That's okay. Okay? This is just simply saying we observed that as water consumption increased, greater weight loss was observed, right? That's what associated with is saying. But causism is implying that it is the increased water consumption that is causing the weight loss to happen. And there is no way we can know that from an observational study. And of course, the reason we can't know that is because of confounding variables. So a confounding variable is just simply a variable that is not included in the study, but that has some sort of effect on the variables of the study. So some possible confounding variables here. Well, I'd maybe encourage you to pause for a moment and try to think of some. Right. One that jumps to my mind right away is exercise. So if you're exercising a lot, then you also have to generally increase your water consumption to keep up with that exercise. And so maybe it's the exercise that's really leading to the greater weight loss. Another thing you've probably heard is that when you're hungry, you should try drinking a glass of water first to see if you're really actually hungry or maybe just thirsty. So maybe it's that phenomena where people are just eating fewer calories due to the increased water consumption that is having an effect on that weight loss. So there's lots of things that could be going on here that are affecting the weight loss that are not included in the study. And whether you can identify those confounding variables or not is almost beside the point, because the fact that it's an observational study means that the confounding variables can be there and can be affecting what you're measuring, and so therefore, whether you can identify them or not, it is not possible to establish any kind of causal relationship. One thing I'll just say here is that you'll see on page 9 there's an example with a number of items to look at. I decided to do that as a forum post, so I'm not going to do that here in the video. That's going to be in a forum post, so we'll just make a little note here that the rest of page 9 is in a forum post. All right, so we just finished making a big deal about how when we have an observational study, it is not possible to establish any kind of causal relationship between variables. I'll start off our treatment of an experiment here by saying that a randomized experiment does have the possibility of establishing causal relationships, and we'll talk about why. So first of all, just a definition, an experiment is where researchers impose a treatment to change an explanatory variable and then note how a response variable is affected. Okay? So explanatory variable and response variable, that's the first time we've brought those up. We've talked about variables, but we haven't used those words to this point. So when we want to determine what variable should be explanatory and which one should be response, what we're looking for is which variable may affect the other. We're not saying that it does at this point, we're just saying which one may have an effect on the other. So if you were measuring the height and the weight of a number of people for a study you're doing, then you would definitely want to make the explanatory variable the height and the response variable the weight. Because clearly growing, changing your height can affect your weight, right? Because you're just adding mass to your body when you do that. However, changing your weight should not have an effect on your height, right? That doesn't necessarily follow. So if you kind of say it both directions, then it becomes kind of, usually becomes fairly obvious in most cases. And also, just to kind of tie this back maybe to algebra class from your past, explanatory, maybe think of the term independent variable. And with response, think of dependent. Okay, so a lot of you in algebra class might have been, independent variable, dependent variable. All right, so in experiments, what needs to happen is they need to be what we call controlled, okay? And here's the real key. So if I ask you, here's a study, Was it an experiment or not? Then what you're looking for is, was there random assignment to a treatment group or a control group? Okay? Is there random assignment to a treatment or control group for each individual that happens to be in the study? So just a little very simple diagram to accompany this is, you've got your sample, so group of people, and then from your sample you're going to randomly assign the members of the sample either to a treatment group or a control. And here's the important part. The treatment group and the control group are the same in every single way except for the treatment. Okay? They are the same in every single way aside from the fact that one's getting the treatment and the other is not. Okay? So, and here's that note, I'm coming back to this again. So only in a controlled randomized experiment can a causal relationship be established, okay? And the reason that is because if you have truly made it so that the treatment group and control group, there was random assignment to each, okay, so that means their makeup should be, you know, reasonably the same, essentially, in terms of being representative of the population. And you have made it so everything is about these groups is the same except for the treatment. Well, that means you've controlled for the confounding variables we were talking about before. Okay? You've controlled for those things. So let me just pop back a couple slides and give an example here. So we're talking about, again, daily water consumption, weight loss over a period of time. So if you randomly assigned subjects in this study to a treatment group and a control group, where you gave both groups, you know, maybe the same type of food to eat, gave them a similar exercise regimen, but just simply told one group, you're going to drink this much water, and the other group, you're going to drink that much water, then you've controlled for all these things like exercise and what food you eat and all that kind of stuff that we're afraid could be affecting the weight loss. Right? We've controlled for that. So that's why an experiment has the ability to establish causal relationships potentially. Now, whenever possible, we want to use a placebo for our control group. So a placebo is basically a fake treatment, so that the subject doesn't necessarily know whether they're in the treatment group or the control group. And so that's called blinding the subject, right? So the subject is blind. They don't know if they're receiving the treatment or not. And so the placebo allows us to do that. There's also something that's very real called the placebo effect, which basically it's a phenomenon where subjects respond to the idea of being treated rather than the treatment itself, right? And so what happens is, if there's a placebo effect going on and you give one group the actual treatment and another group a fake treatment that they can't tell is not the real thing, then the idea is that you would assume that about a similar proportion of people in both groups might experience that placebo effect. And so if there's still a difference in the response between the two groups, then you're feeling more confident that that's maybe the treatment that is causing that difference instead of just like the placebo effect or something like that. I will also say, I don't know if I think I didn't put it in here, but there's also such thing called double blinding a study. Double blinding is where both the subjects and the people conducting the study don't necessarily know who is in the treatment and who's in the control. This becomes really important in studies where judgments have to be made. Like a good example would be you're testing out a drug to treat depression. Well, figuring out if there's positive effects for the subjects is going to entail probably asking them questions and making judgments about whether they are in fact less depressed than they were before. And so there's judgment calls being made by the evaluators. Well, if the evaluators know who's getting the treatment and who's not, then that can affect their evaluation. So in a situation like that, it would be good to also make sure that they are blinded to who's getting the treatment and who's getting the placebo. When we're talking about drugs, like a drug trial or something like that, the placebo is as simple as like a sugar pill instead of the real pill, right? Or injecting some sort of saline solution or something like that instead of the actual medicine. But even with things that don't have to do with medicine, there can be ways of creating a placebo as well. All right, so let's do two examples to kind of wrap up these ideas and kind of solidify our ideas of what's happening in an observational study, what's happening in an experiment, and can we tell the difference when we are presented with a study. So in this one, it says a migraine is a particularly painful type of headache, of course, which patients sometimes wish to treat with acupuncture. To determine whether acupuncture relieves migraine pain, researchers conducted a study where 89 females diagnosed with migraine headaches were randomly assigned to one of two groups. 43 patients were assigned to a group that received acupuncture that is specifically designed to treat migraines. 46 patients were assigned to a group where acupuncture was given in non-acupoint locations. All right, so just think the needles are being put in the wrong spots is the way to approach that. 24 hours after the patients received acupuncture, they were asked if they were pain-free. Okay, so first let's practice this whole idea of explanatory variable and response variable and identifying those properly. So explanatory and response. So our explanatory variable here, oh, and by the way, this again, I really encourage you to pause the video at this point. Don't just kind of go on autopilot and copy down what I write. Pause the video, try these questions yourself first, and then unpause it and see what I come up with. All right, so the explanatory variable and the response. Well, what are they looking at? They're looking at pain relief, and they're looking at whether someone got the actual treatment or not. So, of course, what they are looking for is whether the treatment, right? Whether the treatment might explain pain relief, right? So it's clear that this is the direction it should go, right? We're saying the treatment might affect whether there's pain relief or not, or to the degree to which pain relief is occurring. But certainly pain relief would not affect treatment, right? So like I said, saying it both directions, usually one is very clearly the right way to go. All right, is this an observational study or an experiment? Okay, well, what are we looking for? In an experiment, there needs to be random assignment to a treatment and control group. And that's exactly what we have here, right? They say it right up here. Randomly assigned to one of two groups. So this is an experiment. Right? And the reason is because we have random assignment, and that random assignment is important, to a treatment and control group. And let me just say, the reason that the random assignment is so important, a good example is something that I do all the time is when I want to try something, I new in a class I think will help my students out. I will implement that and then compare it to some past class, right? And there I do have two groups that are essentially kind of a treatment and control of sorts, because one group, the current group, maybe gets the new thing that I'm doing and the other group didn't. And besides that, the classes may be really similar, but the lack of random assignment makes it so that that cannot carry the weight of any kind of causal statement, right? There might be things that are very different about my class from, say, the fall than my class in the winter. And whether I can identify all those differences or not, it doesn't really matter. Those could be there, and so therefore I cannot make that kind of causal statement. So it's that random assignment that is so key. So both the random assignment and those treatment and control groups. But once I've established that, in this case, does the study have the capacity to help establish a causal relationship between treatment and migraine pain relief? The answer is yes, right? Yes. Why? For no more or less reason than because it is an experiment. All right, one other example here. And again, I'd pause this, try it yourself first. What is the preferred treatment for breast cancer that is detected in its early stages? The most common treatment was once removal of the breast. It is now usual to remove only the tumor and nearby lymph nodes, followed by radiation. So to study whether the treatments differ in their effectiveness, a medical team examines the records of 25 large hospitals and compares the survival times after surgery of all women who have had either treatment. Okay, so again, explanatory and response variables, right? Explanatory, response. So like that other one, we do have a type of treatment that we're considering, right? So I guess it's the same as the last one. So treatment type would be our explanatory variable, and we want to see how what responds. Well, specifically, they want us to look at survival times, right? All right, survival times. And so, of course, in this study, the issue here is they want to do a less drastic surgery, which has a lot of positives for sure, a lot less invasive. But of course, the concern would be, well, it's not as aggressive of a treatment potentially, at least in terms of surgery. So would that hurt survival times, right? That's what they want to look at. All right, so in part B, though, is this an observational study or an experiment? Well, here, even though there's a treatment, essentially, there's a treatment group, right, that they're looking at, and I don't want to call it a control, but just another group that's receiving a different treatment. Even though there's those two groups, there's no random assignment to those groups. So we would have to say that it's observational. It's observational because there is not random assignment to a treatment and control group. It's that simple, right? If I can't identify random assignment to a treatment and control group, then it is an observational study, not an experiment. Also, what did we say about observational studies? We said you are collecting the data in such a way that you are not affecting how the data comes about, Well, this is stuff that's already happened, right? And you're just looking at that. So you are doing exactly that. You are not affecting how the data comes about. Is it possible to discover if one treatment causes a different survival time than the other on the basis of this study? And the answer is simple: no. The moment I put observational as my type of study, I know the answer has to be no. No, because the study is observational.